Yes, thank you very much, and thank you for the opportunity to speak here on this very nice event. And some of you might have expected my boss, Christoph von der Busche, here. He was here yesterday evening, he was here this morning, but he had to leave for a meeting here in Berlin. And the ones of you who listen to Urban Keusen might know which meeting that is. So I have the pleasure to explain to you the plans of GASCADE in the field of offshore hydrogen business or transport. And I might give you a short introduction to GASCADE because that explains rather good why we want to invest in offshore infrastructure. So GASCADE is one of the major TSOs in natural gas in Germany. We have connections to several neighboring countries as Netherlands, Belgium, Czech Republic, Poland, and the Baltic Sea. And we used to be the hub for Russian natural gas in Germany, which of course changed within the last 2 years. And now we are transporting LNG amounts in the opposite direction from west to east. We are currently connecting LNG terminals in the Baltic Sea so that we will transport LNG from north to south as well. So what would be more reasonable than to fulfill the same role in the hydrogen market as in the natural gas market right now, which is importing of huge amounts of energy. So the question is, where will the hydrogen come from in future? And looking to that picture here, you see on the one hand our onshore project, which is flow making hydrogen happen, but as well our offshore projects in the Baltic Sea, which is interconnector Bornholm-Lubmin, and in the North Sea, the Aquaductus project. And the question is, of course, so what is the potential offshore? And looking at a DNV study, which was published, I think, beginning this year, we had the idea to see, okay, where is it reasonable to produce hydrogen offshore? And the estimation was that there's a break even, because if you're producing electricity close to shore, it is cheaper to bring the electricity onshore, because the electrolyzers offshore are, of course, more expensive as onshore. But if you go farther into the sea, it will be cheaper to invest in pipelines than in cables. You might know that building a pipeline has the capacity, or one pipeline has the capacity of around 10 offshore cables. So you can imagine that it's much more cost efficient to build a pipeline compared to a cable. So this is the reason why we say, okay, let's develop projects offshore, and not only because it's cheaper to transport, but the studies showed as well that the hydrogen produced offshore is very competitive. So the study says that in 2050, the price for hydrogen could be around €3 per kilo, with transportation costs of around 0.1 to 0.2 euros per kilogram. So far low of 10% of the price for the hydrogen. So yeah, as I said, this is the reason why we have offshore projects. And going a bit more into detail, for the Aquaductus project in the North Sea, we see it's a cooperation between GASCADE and Fluxys, and we develop the project within the Aqua family. And we have, in the first step, we foresee a connection of the Zen 1 area, which is planned for 2029. And we have the idea that we bring the offshore produced hydrogen onshore. But this should be only a first step. Moreover, we have, as a PCI project, or PCI candidate status, because the process is still ongoing, of course, We see this project with a length of 400 kilometers, connecting, let's say, until the end of the exclusive economic zone, or ABZ, in the North Sea, so that we see the potential to connect there, and this is what you can see on the picture as well, to connect different other European countries, as Norway, as of course Scotland, Great Britain, but Denmark, Netherlands as well, let's say, to implement real offshore backbone in the North Sea. So that is why we speak about a pressure level of 120 bar, that we will have a capacity, and I think it's a 48-inch pipeline, so that we can realize a capacity up to 20 gigawatt, bringing hydrogen on shore. This then, of course, won't be only hydrogen produced in the German area of the North Sea, but hydrogen amounts coming, as I said, from Norway or Scotland as well. So huge amounts in the perspective that will be important part for the renewable energy that we need in Europe. As I said, this is of course, not only a GASCADE project. It can't only be a GASCADE project, but many TSOs are involved in that discussions, and we have within the Ostende summit took place in end of April, I think, in Ostende. There was, of course, a declaration of the energy ministers that you can see here. Probably can't read it, but so saying, okay, that we want to develop 300 gigawatt of offshore electricity in the North Sea, which is, by the way, I think about twice the production capacity for electricity that we have in Germany right now. So all over coal and lignite and everything, right? Not only renewables. So this is a huge project, of course. But we, of course, do not need all this electricity in the electricity market, but there will be, and this is in this declaration as well, there will be an important role for hydrogen in that, in the North Sea. And within this Ostende summit, we had a declaration of the involved TSOs as well. So with Energinet and with Gasunie, with Fluxys and all the other TSOs, and we stated that we want to develop an offshore backbone together in the North Sea because we see huge potential. And this is what you can see here on the slide as well. So why do we need such an offshore hydrogen backbone? On the one hand, of course, it means that we will be able in Europe to produce our energy on our own. And I mean, the lesson we learned in the last 2 years is how important it is to be independent in terms of energy production. So this is a very important point. To be independent, of course, means security of supply, but not only concerning independence from other continents, but as well within the kalte Dunkelflaute, right? So in winter times, when no wind and no sun, to be able to produce energy still, and we have storages for hydrogen. I think this story is well known. Cost-efficient transport, I think this is something I already spoke about, very important point. It's much cheaper to transport hydrogen than to transport electricity. And what we have as well is, if we have an offshore backbone, we have, of course, a huge or important part for the internal market of the European Union. This is something we have in the natural gas market, of course. We all are very used to it. And we have competition between producers, between customers in the market. We have huge capacities between the member states of the European Union, which is something we don't have in the electricity market. So internal market of the European Union is a very important point here. Which means, of course, as well, that the green hydrogen that we produce will not only reach Germany, but several member states connected to the hydrogen backbone. Let's say Czech Republic, Poland will be a consumer of a green hydrogen as well. So this is not only a thing for for German customers, but for its European perspective we speak about. So, and the last point, grid connection can be guaranteed, of course. This would be a project as we have it today onshore. So let's say third-party access. We'll see we'll have a regulated offshore system so that we can guarantee grid connections for producers and onshore for customers as well. Yeah, what do we need? Coordination is key. We speak about a European project, so therefore we need a coordinated approach. We need, on the European level, to see where do we need electricity production, where do we need hydrogen production, and how could the connection look like. We need regulation as well. I mean, today it is like, for natural gas, we were used that the producers brought not only Gazprom, but Equinor and Gasco as well. They brought the natural gas to our coastline in Lubmin or in Europipe to Dornum, and then it entered the European market. But here we speak of a European project, so therefore we need some principles for regulation here for the offshore part as well. And of course it could be or should be the same principles as onshore. What is very important as well is that, of course, if we plan with offshore capacity, we need onshore capacity as well to bring the hydrogen to the customers within Europe and to the different member states. So the offshore capacity planning has to fit to the onshore planning, which is very important. And I mean, you all know the discussion we have right now about the starting grid or the core grid here in Germany. So the offshore capacities that we have is a very important point on that. European offshore regulation and grid planning is needed. I told you about the PCI project, so it won't make sense that we have, let's say, a huge infrastructure that foresees a connection to Czech Republic, and then on the Czech side we do not have the needed capacities. So a regulated approach on that point is needed as well, which in the PCI process is very important, and a major point that it must be that several member states must be involved in the PCI project. So this is foreseen in the PCI project. Yeah, coming to an end, I would like to mention again that for GASCADE, we are ready to fulfill the role as the German hydrogen offshore TSO. We are already negotiating these points with all the TSOs in the Baltic Sea, with all the TSOs in the North Sea. We have the projects and we are ready to deliver, and we are ready to invest. Thank you very much. Any questions?
Thank you very much, Dennis. Yes, we need to respect the time. We have time for one question, basically. And this is, we have heard a little bit earlier about the target cost, actually, of $1 per kilogram of H2. And how do you, how can we compare this or put this into perspective with the €3 that you have just mentioned?
Yeah, I mean, $1 per kilo in Texas, I don't know. I didn't calculate that number. I would trust only the numbers we calculated on our own, or which were calculated by DNV. So, and if the hydrogen is in Texas, I mean, there's still the need to bring it to Europe. So I don't know what that would mean for that $1. But I think if we now speak about the perspective for hydrogen, I think €3 per kilo for green hydrogen would be a huge step towards the potential that we need for the German industry, because I mean that should be one of the main goals of all of us to keep the industry in Germany and to have the hydrogen and the green cheap hydrogen that we need for our industry clusters.
Okay, thank you very much, Dennis.